Hey everybody, welcome back. We're about 24% of the way, so we're going to resume. And our next section is called Introduction to Git. So introduction. Git is like a really epic save button on your files and directories. Officially, Git is a version control system. A save is a text editor a save in a text editor records all of the words in a document as a single file. You're only given one record of the file, such as essay.doc, unless you make duplicate copies, which is difficult to remember and to keep track of. So here they're saying you have essaydraft1.doc, essaydraft2.doc, and essayfinal.doc. Now, if you ever worked with people through email, you see that there's always just all sorts of different versions, and that's a problem. And so what Git is all about is controlling your versions. You have your initial build, and then you maybe add a little bit of things to it, and you can save it, and then that creates this record, and it's all in a single file structure. However, a save in Git records records differences in the files and folders, and keeps a historical record of each save. This feature is a game changer. As an individual developer, Git enables you to review how your project grows and to easily look at or restore file states from the past. So you can look at or restore file states from the past. So if you made some changes yesterday that you found out you didn't want the next day, you can restore. You can go back into the ones that you did yesterday. So once connected to a network, Git allows you to push your project to GitHub or other alternatives such as Bitbucket, Beanstalk, GitLab for sharing and collaborating with other developers. Please note, we only support GitHub with our curriculum and will not help troubleshoot the alternatives. While Git looks on your local machine, GitHub is a remote storage facility on the web for all your coding projects. Okay, so Git is your local version, that your local machine's software for saving files in that manner, and then GitHub is a remote storage facility. So it's where you can take all your your local changes, and you can add them to GitHub, and that'll make it so that you have all that stuff saved in a remote place. And this GitHub also has a bunch of other tools too, which I'm sure we're going to go over. So this means that by learning Git, you will get to showcase your portfolio on GitHub. This is really important because almost all software development companies consider using Git to be an essential skill for modern web development. Having a GitHub portfolio will provide proof to future employers as to what you are capable of. In this lesson, we will briefly explore the history of Git, what it is, and what it is useful for. In the next lesson, we will go over the basic Git workflow for Git, which should enhance your understanding and demonstrate why Git is so useful. Finally, you will set up a project with Git that will serve as a template for your future projects. For now, let's learn what Git is and why it's so powerful. So here's our lesson overview. The section contains a general overview of topics that you will learn in this lesson. 1, it'll explain what Git and GitHub are and the differences between the two. Describe the differences between Git and a text editor in terms of what they save and their record keeping. And describe why Git is useful for an individual developer and a team of developers. Okay, cool. And so it looks like we've got a handful of assignments here. Okay, for our first assignment, we're going to read chapter 1.1 through 1.4 in this book about version control. And I had a little peek at this, and I think it's worthwhile for this context for this video to read through it. So, getting started about version control. This chapter will be about getting started with Git. We will begin by explaining some background on version control tools. Then move to how to get Git running on your own system, and finally how to get it set up and working with. At the end of the chapter, you should understand why Git is around and why you should use it, and you should be all set to do so. About version control. What is version control? Version control and why you should care. Version control is a system that records changes to a file or set of files over time so that you can recall specific versions later. For the example in this book, you will use software source code as the files being version controlled, though in reality, you can do this with nearly any type of file on a computer. If you're a graphic or web designer and want to keep every version of an image or layout, which you would most certainly want to, a version control system is a very wise thing to use. It allows you to revert selected files back to the previous state, revert the entire project back to a previous state, compare changes over time, see who last modified something that might be causing a problem, or introduce an issue, and when and an issue and win, and more. Using a version control system also generally means that if you screw things up or lose files, you can easily recover. In addition, you get all this for very little overhead. So local control systems. This is the title of the next paragraphs. Many of people's version control method of choice is to copy files into another directory, perhaps a timestamp directory if they're clever. This approach is very common because it is so simple, but it is also incredibly error prone. It is easy to forget which directory you're in and accidentally write to the wrong file, or copy over files you didn't mean to. To deal with this issue, programmers long ago developed local VCSs, or version control systems, that have a simple database that kept all the changes to the files under revision. So here we have a diagram. It's your local computer is this main box. Check out. So this means the file, the folder, the version of your project that you're currently on, and then it's got there's a version database. So you've got your most recent version, second recent version, and third one. And so your local computer has it here, and then you have your version database. That'll become more clear in the future. So figure 1, local version control. One of the most popular VCS's tools was a system called RCS, which is still distributed that with many computers today. RCS works by keeping patch sets, that is the differences between files, in a special format on the disk. It can then recreate what any file looked like at any point in the time adding up to the patches. So that's called a local version control system. Now we're going to look at centralized version control systems. The next major issue with that is issue that people encountered is that they need to collaborate with developers on other systems. To deal with this problem, centralized version control systems, or CVCS, were developed. These systems, such as CVS, Subversion, and Perforce, have a single server that contains all the versioned files, and a number of clients that check out the files from the central place. For many years, this has been the standard for version control. So we have a version control system server. So in our example, this will be GitHub for us, and then you can have 2 different people working on it, and they can download the whole version database to their own local machines. Centralized version control systems. So here, they're just explaining figure 2. The setup offers many advantages, especially over local VCSs. For example, everyone knows to a certain degree what everyone else on the project is doing. Administrators have a fine-grained control over who can do what, and it's far easier to administer a CVCS than it is to deal with local databases on every client. So having a central tool makes it so that multiple people can collaborate to the version control system. Cool. So however, this setup also has some serious downsides. The most obvious is that a single point of failure that the centralized system represents. If the server goes down for an hour, then during that hour nobody can collaborate at all or save version changes to anything they're working on. If the hard disk and the central database is on becomes corrupted, the proper backups haven't been kept, you lose absolutely everything. The entire history of the project, except whatever single snapshots people have happen to have on their local machines. Local VCSs suffer from this problem. Whenever you have the entire history of the project in a single place, you risk losing everything. Okay, so that was central virtual control server. So now we've got a distributed version control system. This is where distributed version control systems step in. In a DVCS, such as Git, Mercurial, Bazaar, and Darks, clients don't just get out the latest snapshot of the files, rather they fully mirror the repository, including its full history. Thus, if any server dies, then the systems were collaborating via the server. Any of the client repositories can be copied because of the server back up to the server to restore it. Every clone is really a full backup of all the data. Oh, okay. So I was wrong about this. This is not like GitHub. This is maybe a different system that I've never used before. So here, basically, each computer has all of the files, and then they can share back and forth. So distributed version control. Furthermore, Many of these systems deal pretty well with having several remote repositories they can work with, so you can collaborate with different groups of people in different ways simultaneously within the project. Within the same project. This allows you to set up several types of workflows that aren't possible in centralized systems, such as hierarchical models. Okay, moving on to chapter 2. Getting started. A short history of Git. As with many great things, Git began with a bit of creative destruction and fierce controversy. The Linux kernel is an open source software project of fairly large scope. During the early years of the Linux kernel maintenance, changes to the software were passed around as patches and archived files. In 2002, the Linux kernel project began using a proprietary DVCS, a distributed version control system called BitKeeper. In 2005, the relationship between the community that developed the Linux kernel and the commercial company that developed BitKeeper broke down, and the tool's free of charge status was revoked. This prompted the Linux community, and in particular Linus Torvald, the creator of Linux, to develop his own tool based on some of the lessons that he learned while using BitKeeper. Some of the goals of this new system were as follows. So number 1, there was speed, simple design, a strong support for nonlinear development, meaning you can have tons of different branches, thousands of parallel branches. He wanted it to be fully distributed, able to handle large projects like the Linux kernel efficiency, so speed and data size. Since its birth in 2005, Git has evolved and matured to be easy to use and yet retains these initial qualities. It's amazingly fast, it's very efficient with large project, and it has an incredible branch system for non-linear developers. And then they say, look at this Git branching. That's in chapter 3, and that's not part of this, so we're not going to get off on the thing too much. So we're going to go to chapter 1.3 now. Okay, getting started. What is Git? What is Git? What is Git in a nutshell? This is an important section to absorb because if you understand what Git is and the fundamentals of how it works, then using Git effectively will probably be much easier for you. As you learn Git, try to clear your mind of the things that you may know about VCS, such as CVS, subversion or perforce. Doing so will help you avoid subtle confusions when using the tool. Even though Git's user interface is fairly similar to the other VCSs, Git stores and thinks about information in a very different way, and understands these differences will help you avoid becoming confused while using it. So what they do is they say they're taking snapshots, not differences. The major difference between Git and other VCS, subversions and friends included, is the way Git thinks about its data. Conceptually, most other systems store information as a list of file-based changes. These other systems, CVS, subversion, perforce, bazaar, and so on, think of the information they store as a set of files and changes made to each file over time. This is commonly described as delta-based version control. So they have check-ins over time. It looks like there's 5 versions. You've got file A, B, C, and they change at various intervals going across the check-ins over time. So storing data as changes to a base version of each file. Git doesn't think of or store its data this way. Instead, Git thinks of its data more like a series of snapshots of a miniature system. With Git, every time you commit or save the state of your project, Git basically takes a picture of what all your files look like at that moment and stores the reference to the snapshot. To be efficient, if files have not changed, Git doesn't store the files again, just a link to the previous identical file it had already stored. Git thinks about this data more like stream of snapshots. Okay, cool. So as the check-ins over time slowly modify, the next time you see here, it just continues across, and they just save the A1 as a copy, and here they save B, and here they save C. Storing data is a snapshot of a project over time. This is an important. Okay, so now let's see. Nearly every operation is local. Most operations in Git need only local files and resources to operate. Generally, no information is needed from another computer on your network. If you're used to CVCS, where most operations have that network latency overhead, this aspect of Git will make you think that the gods of speed have blessed Git with unworldly powers, because you have the entire history of the project right here on your local disk. Most operations seem almost instantaneous. For example, to browse the history of the project, Git doesn't need to go out to the server to get the history and display it for you. It simply reads it directly from your local database. This means you see the project history almost instantly. If you want to see the changes introduced between the current version of a file and the file a month ago, Git can look up the file from a month ago and do a local difference calculation, instead of having to either ask a remote server or pull an older version of the file from the remote server to do it locally. This also means that there is very little you can't do if you're offline or off VPN. If you get on an airplane or on a train and want to do a little work, you can commit happily to your local copy, remember, until you get to a network connection to upload. If you go home and can't get your VPN client working properly, you can still work. In many other systems, doing so is either impossible or painful. In Perforce, for example, you can't do much when you aren't connected to a server. In Subversion and CVS, you can edit files, but you can't commit changes to your database because your database is offline. This may not seem like a huge deal, but you may be surprised how big the difference it can be. And so I'm really unfamiliar with Perforce or Subversion. I've only used Git throughout my entire coding journey. Next section. Git has integrity. Everything in Git is checksummed before it is stored, and it is then referred to by that checksum. This means it's possible to change the contents of any file or directory without Git knowing about it. This functionality is built into Git at the lowest levels and is integral to the philosophy. You can't lose information in transit or Git file corruption, with Git being able to detect it. The mechanism that Git uses for checksumming is called SHA-1 hash. This is a 40-character string exposed by a hexadecimal character and calculated based on the content of the file or the directory structure in the Git. A SHA-1 hash looks like this. So here's a SHA-1 hash. You will see a lot of these values all over the place in Git because it uses them so much. In fact, Git stores everything in the status base not by the file name, but by the hash value of its contents. So we'll talk about that later. Okay, Git generally adds data. When you do actions in Git, nearly all of them only add data to the Git database. It is hard to get this system to do anything that is not undoable or to make it erase data in any way. As with any version control system or VCS, you can lose or mess up changes you haven't committed yet, but after you commit a snapshot into Git, it is very difficult to lose, especially if you regularly push your database to another repository. This makes using Git a joy because we know that we can experiment without the danger of severely screwing things up. For a more in-depth look at how Git stores data and how you can recover data that seems lost, let's see undoing things. So undoing things is just a whole other section on this book, and in the hopes of not going down wormholes, we're going to just skip that for now. So the 3 stages. Pay attention now. Here is the main thing to remember about Git if you want the rest of your learning process to go smoothly. Git has 3 main states that your files can reside in: modified, staged, and committed. Modifying means that you have changed the file, but you have not committed it to your database yet. Staged means that you have marked the modified file in its current version to go into your next commit snapshot. And committed means that the data is safely stored in your local database. This leads us to 3 main sections of the Git project: the working tree, the staging tree, and the Git directory. Cool. Working tree, staging tree, and then Git directory. So you check out the project, you stage fixes, you make them staged, and then you commit them, and then they go to the directory. This might seem really difficult at first, but once you become familiar with Git, this becomes very, this is just the day-to-day stuff. So working tree, staging area, and Git directory. The working tree is a single checkout of one version of the project. These files are pulled out of the compressed database in the Git directory and placed on your disk for you to use or modify. The staging area is a file generally contained in your Git directory that stores information about what will go into the next commit. Its technical name is the Git, in Git parlance, is the index, but the phrase staging area works just as well. The Git directory is where the Git stores the metadata and the objects database of your project. This is the most important part of Git, and it is copied when you clone a repository from another computer. The basic Git workflow goes something like this. You modify files in your working tree. You selectively stage just those changes you want to be part of your next commit, which adds only those changes to the staging area. You do a commit which takes the files as they are in the staging area and stores the snapshot permanently to your Git directory. If a particular version of a file is in the Git directory, it's considered committed. If this has been modified and was added to the staging area, it is staged. And if it was changed, since it was checked out but has not been staged, it is modified. In Git Basics, you'll learn more about these states and how you can either take advantage of them or skip the stage entirely. Okay, cool. So let's open up a terminal, and I'm just going to go through these real quick just to see if I can show. Now, I'm not even sure if Git's set up on this machine because I'm still on a brand new machine that I haven't used for web development stuff. So we can say git branch, or git, I think it's -- version. Cool, so it says that we're in Git version. So let's change directories into the desktop. And now if I list that out, there's only 2 programs here. So we're going to start a new project. So make directory, and we'll call it Git Basics. And now if I change directories into Git Basics, and we list there, we have an empty file. So now I think we can go git init, which means starts a new project. Okay, cool. And now we can go git status. That tells us there's nothing to change. So here's where I want to explain this working directory staging area. So right now there is no, so now that we've created it, we did git init. If we do ls-a, we can see that now there's a git file in here. Before there was no git file. And I think if we were to cat git, that would get us, oh, it's a directory. Okay, yeah. So you can change directories into Git. And if we were to list that out, it shows us this is the basics of the Git. So once you did git in it, it started this whole thing. So I'm going to change directories and come out. And now I'm just going to touch a file that just says first.md. Now, if we were to go git status, we'd see that there's a file that's not staged there. So our working directory has staged fixes, meaning this file, that have not yet been added to the staging area. And to add it to the staging area, we would want to go git add first.md. And now if we were to go git status, we have it as a green file. So now it's in our staging area. And so our next move is to commit it. And so you would say git commit, and then you want to add a message to it like first commit. Cool. And now if we do git status, you'll see on branch main, nothing to commit, working tree. And we don't have anywhere to push to yet, so that's outside of the scope of this. But what we did here was we created a file, we staged fixes, and then we added it to our staging area. So we git add first.md. So we added this change, which was just a blank file. And then once we added it, it was in our staged file. So we had this green one here. It said changes to be committed. And then we changed them. So we commit and we added them to the Git directory. And now if we do git status, we have on the main branch with nothing to work on. So that's basics of how Git works, just coming off quickly. And that's interesting to see that it's Git is on the base branches of the new MacBook Pros. Okay, cool. So that wraps up 1.3, and they asked us to go through 1.4. So I wouldn't be surprised if 1.4 just goes over what I just went on. Okay, cool. 1.4 is quite quick. So getting started, the command line. The command line, there are a lot of different ways to use Git. There are original command line tools, and there are many graphical user interfaces of varying capability. So that's like Git-K is one. A lot of different Git command line tools or graphic user interface. For this book, we'll be using Git on the command line. For one, the command line is the only place where you can run all Git commands. Most all GUIs implement only a partial subset of Git functionality for simplicity. If you know how to run command line version, you can probably also figure out how to run GUI versions. Agreed. While the opposite is not necessarily true. Yeah, if you learn how to do this with a GUI version, it's a good chance that you won't know it on the command line, but if you learn the command line, it's easy to pick up all the GUI tools. Also, while your choice of graphical client is a matter of personal taste, all users will have the command line tools installed when they're available. So we will expect you to know how to open terminal in Mac OS or prompt or PowerShell in your Windows. If you don't know what we're talking about here, you may need to stop and research that quickly so that you can follow the rest of the examples. Well, with Mac, you press Command, Spacebar, Terminal, and that's how you open that up. So cool. We're done with this section of what they want for us. So I just press Command W to close this first section. We've completed this one. And so next up, we're going to watch this video, which I'll link here. All right, that was a pretty cool video. Let's see, we'll move on to the next one. So we saw that one, about how Git can improve your workflow of both an individual and a team of developers. And so now we'll watch this video with some history of Git and GitHub. All right, that was a cool video too. Git is a technology used in the command line, while GitHub is a website you can visit. So yeah, it just links us to GitHub there. If you haven't yet installed Git, visit Setting Up Git lesson. Now, my computer came pre-installed with it, so I'm not going to have to worry about this. I hope that this doesn't mess anybody up, but it'd be hard to do a real video about how to set up Git knowing that I already have it installed. So take a look at the Odin Project's very own GitHub repository. So I just open that in a new tab. This is where you'll find all the lessons are stored, and while you're there, you can look at the contributors to gain an appreciation for how Git records all collaborative efforts on, and how GitHub visually represents this. Cool. So I think contributors. Yeah, let's just open the link that they had there. So yeah, the contributors page, you can see 105 Iron seems to be the most active at the time of checking this out. And you can see each one of these are either some code requests or comments or anything like that. So you can see somebody's activity. It looks like 105 Ron has been the most consistent since 2017. And it looks like right up until now. So that's a pretty cool thing about this. GitHub's just got so many cool little features. And we'll just be going through a lot of them as we go through. But the curriculums here, and then the Odin Project will have more different repositories here. It looks like they've got 3 that are pinned to the top, and then it looks like there's a list of just huge amounts of repositories. Not too much, really, though. So we can take a second to look through that, but let's not go down a wormhole right now. All right, so now we'll do our knowledge check. So this section contains questions for you to check your understanding of this lesson on your own. If you have trouble answering a question, click it and review the material that it links to. What kind of a program is Git? Git is a command line interface tool that's built into Linux operating system. Epic save button. Okay. Okay, yeah. It's a version control system. Yeah. What are the differences between Git and a text editor in terms of what they save and their record keeping? Whereas a text editor saves entire files, Git just saves snapshots of the project, and it will save based on a continuous pattern. And so if there's files that were not edited, it simply clones them, and so it keeps a very good versioned save button of your project. Does Git work at a local or remote level? Both. You can locally push code to a project, and then you can actually use other projects to push code there. Let me see if I'm right about that. While Git works on your local machine, GitHub is a remote storage facility on the web. Okay, cool. That means that by learning Git, you will learn to showcase your portfolio on GitHub. Okay, so I guess the right answer for this, I was wrong, is that Git is a local, and then the remote is GitHub. And so the next question, does GitHub work at a local or remote level? The answer is remote level. However, there is GitHub Desktop, which I would argue is local now, but that's outside the scope. Why is Git useful for an individual developer? There's so many different ways that Git is useful for an individual developer, but above all, just the version control system. That's kind of the core of it, but then it can also be used to deploy code to different projects and things. So Git's especially useful. Why are Git and GitHub useful for a team of developers? It allows them to work together effectively. So yeah, we have some additional resources, but for now, for the scope of this one, I am not going to go through these. But I recommend that you guys do. So hope you guys enjoyed this one. I'm going to mark this one complete, and we'll see you in the next lesson.